Good evening. Tonight I'm going to show you how to draw a custom handle for cabinetry and then take it from the design stage all the way to the finished product and walk you through the machining steps here. So the first thing is, you've got to draw your design. There's some cuts involved, so I won't take too much, but how I'm designing this is, how I'm envisioning machining it too. So when I'm drawing this, I'm thinking about cutting it and how am I going to hold this, and what am I going to do one at a time, or am I going to do, how many of these do I need to make? Do I need to make 20, 30 of them? So that's always going through my head when I'm every step that I'm doing, from this step here of drawing it to actually machining it. So you're already started looking at how's this piece going to be set up on the table, with these vertical cuts and a pocket on the back. So I would say, all right, we already determined that this is going to be the top side of it, and we're going to come through and hog this out in one big board. We're probably going to do this hollow here. Let's look at the next cut here. Now we've created a profile, so that's going to be our last cut. Basically, is a profile. So the first cut is coming through and clearing out this section. Then the next cut is go through this hole. There's a couple more things that we're going to add here to it. Some fillets. The fillet goes on the top side. We know that this is going to be the bottom, and I can't reach that with the cutter, so it's a secondary process, basically setting up a router with a bearing wheel and a radius cutter to make that finish there. And then before we do the profile, we're going to poke these holes in. So we've got, we can make a jig with that same spacing to lay our holes out on our cabinetry to match, so we know exactly hole placement. And either you can put thread inserts, drill these to a threaded wood insert, so when you transfer your holes in your doors. Plus, what I found was if you didn't put an insert, these areas would split because of using oak or a harder wood. So you may want to think of that you probably got to remember to leave enough material here to put a threaded insert for wood in them so they don't crack, because I did skip that step and did crack a couple of them, so I ended up having to drill pilot holes, and that sort of solved the problem too, because I'd only center drilled the center points. I didn't really put a like a tap drill size in there, so I went back and put a pilot hole, and that seemed to give enough relief that I wasn't cracking, on the edges here. So that's how I salvaged that mistake. So anyways, so we've got our basic part drawn. So now we can take this part right out of SolidWorks, and actually, because I'm more efficient in SolidWorks, I draw in SolidWorks, so I can pull it right out of there and then bring it over into Fusion. And basically what I did in Fusion was I started with one single part. Let me see if I can turn these off here. Okay, that didn't do nothing. Not sure what that does. But I brought in one part and basically copied it multiple times horizontally and then once vertically. So this, now you're going to start seeing what I did. Because I don't have it drawn as one big board, I had to make some boundaries. So when I do my clearing on this cut here, I had to draw a rectangle, and all I did was, in this software, this CAM software, it's also got modeling software. So in the model in here, I actually I did all the pattern here in the modeler, and then here I just drew the sketches. As you can see, if I shut them off, you don't see them. So if you want to look like you're really smart, you can shut those off after you program it, but I usually leave them in there because I use them as points of reference to stop and start my tooling. So we'll go back into the cam. So that's sort of all my little tricks on how I did that. So now I know that if I program, now I can call this a pocket. Each one of these I couldn't call a pocket because they're not a closed pocket. So by drawing this sketch, I created a closed pocket, and I'll be able to show you. So it's a pocket. So I only, actually that's the pocket for the center of this cutout. So the actual pocket that I was talking about was this. So now when I program this, I can program it as a pocket because I've drawn a rectangle, and that rectangle will be picked up as a self-contained pocket. And all I'm doing is, in this, is let's go up in here and we'll edit this pocket. So when I pick my geometry, you can see what I picked. I picked those two rectangles, and it's two chains, and so that created two paths for my cutter to run for pockets. And then for the top height, right here, these are the only two you're really worried about. It's this top height and this bottom height. I always use model the top, so I'm always starting from, think about it, you got to zero out your tool. So you're going to zero out your tool. If it's a finished surface, you're going to zero out your tool on this top piece here, right on that face. So that's what model top means. The model, and then I use model top again because I want to use the same point as same datum to create my Z offset. So I now want to cut this pocket for your fingers to go in behind this handle 3/8 of an inch deep, and it's always in a negative direction. And then always doing my conventional cutting. The things I mess with, sometimes you'll get better wear on a cutter if you you take that step over and you reduce the step over. This one I left it pretty close, and the cutter size is 3/4, so I'm 20 or whatever little different. So anyways, so now you've seen that. What else I want to show you? Step downs, ramping in. You can do I like to do plunge. You could do plunge outside. I usually just use this plunge here, and then I change that's about all I changed there. I didn't cover here. Multiple depths. I took that all in one pass because it was one big solid board, but you could change it to roughing step downs, to taking maybe 1/8 of an inch at a time. And what that does, so now I've got 2 steps in there, or 3 steps in it. So I'm taking 3 cuts. My cutter I'm going to use, so let's go back to that where I picked that and how I did that. Right here, select the tool, 3/4 face mill. You can actually left click on it and edit the tool. So here's where you set up your tool lengths, your tool diameter, your flute cutting length. So I know I got a 1/2 inch of flute, so wouldn't be no big deal. In my router's a 220 router, and it's rack and gear, and it's going to handle this. So I'll go back here, and I'm not too worried about surface finish because it's on the back side. The one thing that I am sort of worried about are those tabs. If I put too much pressure on there, it would break that, and in this circumstance, but remember I'm cutting in a much larger perimeter board, so always think of that, because if I only had just that material and I'd already done some of this work and I tried to make that cut, it'd blow those ears right off there. So think about that. So in this circumstances, I'd just go a single pass at it and maybe go a little bit slower on my feed. And so that's how I would do that. And then the rest is basically, what this is going to show here. So let's take a look at this. So it's got a nice simulation. You can turn the stock on or the stock off. So now you're seeing what I've dealt with, and I guess I sort of missed that piece of showing you how did I come up with that board size and what drove that. So let me go back. The biggest thing that you've got to remember is the setup, and because this is going to determine how you put your wood in your machine on your x-axis and your y-axis and your z-axis. And if I'm working from the top of my wood like I am here, I'm always miking, measuring out the thickness of that wood so I know how far I got to cut through, if I'm going right to my spoil board, or if I've got something under there that I'm going to hit, a setup block or that. I'm always thinking about that. And then just like I talked about, how can I hog that out? Well, if I made my block a little bit bigger, I could hog a good portion of that out without, that can save me a tremendous amount of time. So, and then I didn't discuss how I guess I didn't cover that, how the holes got in there. So you're going to be able to see basically everything. So the stock thing here, right here, it's going to show your dimensions. So that's my board, what I've got to rough out my board piece. That's what I'm bringing to the table to start. 3/4 inch thick, 10 inches wide by 24 3/4. So that told me what I needed to prep for that setup. As you see, these failed. Sometimes when you're in that setup, it's going to need the tools regenerated. So basically, if you ever see that and it reds out, you've got to just click back on it and generate, and that will regenerate the tool to post a process. This is the process poster. Always I pick milling because that's what I'm doing. I use Mach 3, but if you go in here, there is a lot. What I'm seeing is like the Shark and some of those other CNC machine manufacturers have proprietary software that you can't use Fusion with, and you're forced into the V-Carve or whatever the other products are out there, or softwares that you have to use. But I'm sure glad I've got Mach 3, because obviously I'm a designer by trade, and this the closeness of SolidWorks to this Fusion and the ease of use. I think there was like a quick 10-page tutorial or something for this Fusion on how to run this cam, and I mean right after I went through, I was already programming and running my first program. So that's how pretty easy it is. So back to this, make sure you're in milling. Mach 3 is what I'm using here. Put in the name. So I'm only exporting one cut at a time. So this, naming conventions is always helpful. I always put my cutter diameter, and then it's always good to know how deep you're going. 375, DP, and then you could always put wood or let's go 0.75 thick. doesn't matter what you put, but I tell you what, when I go to run these programs, I know what the name, I know what size cutter I need, I know, you know, how deep I'm going, and I know how thick of wood I need to start with. So it takes a lot of that guesswork out. And this is what the process or the post looks like. It wants to dump it in this local, so you've got to go back and, you know, add it to, you know, where you want it, and save it. And what it'll do, it'll pull up the editor. And what I usually do is, you know, code that I don't need, I can isolate. Oops. Go in here and just isolate this stuff. You know, that was going to drive right at the beginning my Z up to 0, and I don't have a limit on my Z, so I mean it would have crashed my computer or my Z travel. Here there's just the same thing, Z0. So this is wanting to take it back to the table home. Or actually it wants to go back to the Z0 set on the actual program. And then this Z0 here would crash my head. So what I usually do, I don't need any of that. I'll let it stop where the last code stops. M30, it just rewinds the program. And then I just go back in here and save it. And this is that's the file there that so let's go look at that. So it's in here. So there it is. Let's look at details, and it's a tab file. So that's what it exported, but it just depends on what programming software you run. So let's go ahead and simulate this and just show you what happens. So I like this simulator because it shows you the cutter. So you can see when you goof up, or you know, if you don't have a small enough cutter for the radius, you know, like in this corner up here. So that was telling me, okay, I need to bring in another cutter size. So I dropped down to a smaller cutter here, and that's what I'm doing there, just doing a contour with a smaller cutter to get a tighter radius in the corners. And then I'm doing my profile with tabs. So you're seeing the tab connection, and all I used was just a little Dremel vibration tool to cut the tab up. Made a little jig for my small router and put a bearing radius bit in there, and zing zing, I was done with it. So there's just a quick tutorial on how that works.